I'm going to introduce you today to a robot vacuum cleaner that navigates in a totally different way with a 360-degree camera, and which gives unprecedented suction for a robotic vacuum cleaner thanks to our digital high-speed motor. Both these features are unique. Nobody else has them. The pattern you're seeing on the walls around here is typical of the random movement of a competitor robot. Now, the reason why a random movement and not perfect navigation doesn't work is that a robot is necessarily powered by batteries. So if you want powerful suction, and if you want the robot to clean your room properly, then you mustn't waste the battery power. You must navigate correctly. Now, if I'll move on to the next slide. This is the 360-degree camera. This sits on top of the robot there. You can all see it. And it is continuously filming the room as it travels around. And it's taking dimensions from the picture, what it sees, 30 times every second. Because of that, it's firstly building a map and a plan of the room and the furniture. And secondly, it's taking trigonometrical dimensions from various points in the room so that it knows exactly where it is. Now, I'd like to describe to you, to get you to imagine what would happen if you went into a new room for the first time. You would notice certain features that you need to know. You would notice the table so that you don't bump into it. You would notice where the edge of the sofa is that you have to clean. You would notice where the wall is. Now, you don't look in great detail at everything in that storage unit over there. You don't look in great detail at the plant. You take in the little bits of information that you need to know in order to walk around the room carefully and safely, and in order to clean the room. And that is precisely what this camera and the brain of the robot is doing. It's taking in the necessary information and producing a plan of the room. So the robot starts from the docking station. It comes a bit into the room. It turns around and looks back at the docking station. That way, it knows the shape of the room, and it knows where the docking station is in the room. So wherever it ends up in the apartment, it can always find its way back to the docking station. It then goes and cleans, now I'll show you this. It cleans in a spiral, an outward spiral. Now you'll notice that it's doing one cleaning path immediately next to the one it's just done. It never overlaps itself. And you can see it going around this room, forming a map of the room, and this is speeded up, obviously, and it's now doing the whole apartment. So what you're seeing here is an actual plan of the apartment that's being cleaned, all the rooms and the corridors. And down below you, and again it's speeded up, you're seeing what the camera is seeing in order to be able to form the map of the room and to navigate around. Now, it knows where it's been, it knows what it's done, it knows where it's been, it also knows what it hasn't done. Now, if there's a bit in a room that it hasn't done, it switches the vac motor off because that consumes power, and it goes across to the bit that it hasn't done, switches the vacuum motor on, and does that bit. Now, the key to all of this is having a very powerful digital motor, which is this, which goes at over 100,000 RPM. And the second secret is having a 360-degree camera so that you know exactly where you've been, you know exactly what you haven't done, and you've formed an exact plan of the room or the apartment. So you're not wasting battery by cleaning one spot more than once, and you're able to use the maximum amount of suction. And to give you an idea, this produces at least 20 times the suction of other robots. So you're not wasting this powerful suction, you're putting it to its best use to clean the flat or the apartment. So I move on to the next slide. Now, I'll talk a little bit more about our digital motor. We've been developing this over the last 10 or 15 years. It's very small, as you can see. It has the electronics with it. It's a digital motor. So it's not a mechanical motor, it's a digital motor. And it's controlled by a chip. The pulses, the repulsion, the attraction are controlled by a chip about 60,000 times a second. And it goes at over 100,000 RPM. And it's very efficient. It's about 87% efficient. So this enables us to get a great deal of power from a very small motor very efficiently. And no other manufacturer has got anything like this motor. Now the second feature, let's have the cutaway, that's probably, thank you very much, are our cyclones. We're the only people who have cyclones on a robot. That's very important because we don't want to have our suction reduced by any clogging or blocking caused by fine dust. So our 8 cyclones in a double system trap fine dust down to half a micron so that it doesn't go onto the filters and doesn't come out into the room. In addition to that, we have a primary filter and a secondary HEPA filter here. So no air, dust, is going back out into the room. That's very important because some robots actually create dust with those flicker things that they have on the edge of them. They flick the dust upwards. And other robots actually expel dust. So picking the dust up in the first place, having 20 times the suction of other robots, and then keeping the dust inside the robot is what a good vacuum cleaner should do. Now, the other important thing is the brush bar. Now, you'll see that our robot is comparatively small. And it's small because we want it to be able to get into small spaces. A bigger robot than ours will miss out on cleaning a lot of areas because it just can't get there. So ours is small, so it can get there. And the brush bar is the full width of the machine. So wherever the robot has been, it has cleaned. And you'll notice on other robots, they have a much smaller brush bar in the middle of the machine. So if they go into a tightish spot, they can only clean where the actual bristles have been. Ours is the full width. We also have carbon fiber bristles. We have these because on hard floors like this, dust will stick to the hard floor by static. We use carbon fiber bristles to break the static of the dust on the floor, and no other manufacturer has these. Now you'll notice that we don't have wheels, but we have tank tracks. Now there are 2 reasons for these. One is that tanks are very good at climbing up objects onto a thick carpet or something in a door that you have to climb over. So tank tracks are very good at that. Also, tank tracks don't slip. So a wheel slips, tank tracks don't. And that's very important if the robot is half on a carpet and half on a hard floor. It would not go in a straight line if it had wheels. With tank tracks, it can go absolutely in a straight line. Now, we have, to the point where I get out my phone, we have an app so that you can control this phone, put it on from your office, you can program it, you can contact the help center, a fault guide is in here as well. And also from the office or wherever you like, you remember the plan you saw of it cleaning the apartment? You can have that on your iPhone or your smartphone as the robot is cleaning your apartment. So you could be in the United States, you could instruct your robot to clean your apartment, and you could check up that it's doing your apartment. Similarly, the Wi-Fi connection enables us to interrogate your robot, to download updates, and all the sort of things that connectivity gives you. So just to sum up, we've got a 360-degree camera which maps the room and tells you very precisely where you are in the room so that you can navigate accurately and properly without wasting energy and making sure that the room is cleaned or the apartment is cleaned thoroughly. And we have powerful suction through our high-speed digital motor, and then we separate the dust so that it's not blown back in the room by our multi-cyclone technology. And now I'd like to move on and
Dyson 360i ロボット掃除機は360度ビジョンシステムを採用しています。これによりロボットは自分の位置を正確に把握して効率的かつ規則正しく掃除をします。既存のカメラシステムでは私たちが求める製品は開発できませんでした。一方向にしか向かないカメラではなく、周囲を一目で見渡せるシステムこそが私たちが求めているものでした。このシステムの利点は現在地を把握するために回転する必要がないこと、そして一部の視界が遮られても問題ないということです。これはロボットから見た景色をパノラマにしたものです。360度が同時に見えているので回転することなく、目印となる部屋の特徴を見つけ自分の位置を把握します。ロボットが動いても画像は常に連動しているので対象物を見失うことはありません。ナビゲーションシステムはとても高性能なので現在地と周囲の情報を同時に処理することができます。赤外線センサーによって障害物を検知しそれらをマッピングします。それにより部屋の中の障害物を避け規則正しく掃除をします。掃除するルートはとてもシンプルです。例えばこのように動いてこの位置に達したとき、前進するのではなくこのように曲がります。四角螺旋状に動きます。効率的に隙間なく動き無駄がありません。規則正しく動くので同じ場所を何度も掃除して時間を無駄にすることもありません。実際の部屋にはもちろん障害物があるでしょう。同じく四角螺旋状に掃除を進めていきます。家具に近づくにつれスピードを落とし、本体1台分の距離だけ進み反対方向に向かいます。そして別の家具によって進行が妨げられると新たに前進できる一番近いポイントに戻って掃除を続けます。ロボットがきちんとマッピングしているからこそ掃除をした場所、掃除をしていない場所がわかるのです。
ダイソン 360i ロボット掃除機は確実に掃除ができる高性能なロボット掃除機として開発されました。確実にゴミを取り除くには高い吸引力が必要です。そのためにはパワフルなモーターが必要でした。そこで我々は世界最小最速のダイソンデジタルモーターを開発しました。このモーターは従来型に比べてパワフルな吸引力を生み出します。この機械で吸引仕事率を計測してみましょう。ダイソンの方が圧倒的にパワーがあることが明らかです。それでは強力な吸引力がどれほど重要であるかをお見せしましょう。この製品はどれだけゴミを取り残したでしょうか。ゴミは溝の間にもまだたくさん残っています。ダイソンのロボット掃除機は明らかにより多くのゴミを取り除きました。ダイソンのクリーナーヘッドは機体とほぼ同じ幅があるので通過する場所すべてがきれいに掃除されるのです。これはロボット掃除機によくあるサイドブラシ、クリーナーヘッドを保管するものですが、ゴミを集めるというよりはこのようにゴミをまき散らし宙に舞い上がらせています。これは避けたいことですよね。次に重要なことは空気とゴミを分離すること。ダイソンは外側にある大きなサイクロンと 内側にある8個の小さなサイクロンで微細なゴミを分離します。内部に強い気流を作ることで微粒子さえも空気から分離することができます。ロボット掃除機では走行性能が重要です。ベルト駆動式天輪により高い走行性能を実現しました。一般的な車輪では途中で止まってしまったりコースを外れてしまうことがあります。ベルト駆動式天輪なら障害物を乗り越えられるので持ち上げて軌道修正する必要がありません。
We're just going to set up a demonstration here of a competitor robot cleaning along this hard floor here and the Dyson robot cleaning along the hard floor here. I just want to say that it's taken us 16 years to develop this robotic vacuum cleaner. And Mike, who's an engineer who's just behind here, has been working on it for 16 years with me. So it's a very emotional moment for both Mike and myself. And I'm very pleased to be launching the robot here in Japan, which is where I first sold my first vacuum cleaner. So I'm very, very pleased to be here. So here we are. We have a competitor on the left and the Dyson on the right.
Could you start?
One of the things especially that you should look at is the dust in the crevice.
On the back.
Yeah, yeah. Is it still there? Is it still there?
Mr. Dyson, could you look at those cameras on your right?
On the
Those
right,
people.
yes.
Thank you.